Exactly about a year ago, we came and talked about IoT Assurance, one of the solutions that allows you to do cloud scale PPSK with unmatched visibility, key lifecycle management, policy, traffic engineering. Uh, at that time, we also showed you a very sneak preview of what we were building up to. And I'm really super stoked and excited to be here to launch the Mist Access Assurance solution. As you heard from Tom, it came about from the White Sand acquisition that Juniper did back in 2021. But last year, we said we were going to be intentional about integrating it the right way, do it the right way. And I'm happy to be here saying that we have actually done it, accomplished it. I'm going to turn it over to Slava. Slava has been one of the product champions and a lead on the product team that has carried that vision forward up until this stage. And I'm going to be Slava's able-bodied assistant for the next 45 minutes. So take it away, Slava.
So I'm Slava, part of the Juniper Mist product management team. And today we're going to talk about NAC. Before we will start talking about NAC, we'll actually talk about some history. And what you'll see is a time chart. And we will talk about how NAC evolved over the past, well, almost 20 years, and how at the same time, different NAC use cases have evolved, right? That's going to be important for, how we got here moment, basically. So if we start at the early 2000s, back then, we only had corporate access use cases. And you see a laptop there, but it's actually not a laptop. It's supposed to be a workstation that we used to plug in, a wired port back in the day. Back in the day, Cisco ACS was #1 product, right? That was the AAA server that started all the way from authenticating dial-up modem users. But then when we look at 2007, we see iPhone introduction, and then people started to want to get a guest Wi-Fi access. At the same time, we see additional products coming out from Cisco back in the day, like NAC Guest, NAC Profiler. We see a Megapod doing the same thing to address that guest access use case. 2010, we have BYOD, we have iPad introduction. At that time, people realized that, actually, we can bring our personal devices to work and pretend that we are working. So BYOD use case. At this point, we see Aruba acquires a Megapod in the vendor, the guest access BYOD solution and profiling solution, and takes it over. Now, 2011, this is where there was an idea, okay, why don't we combine all these multiple standalone solutions into one? Well, welcome to Cisco ICE in 2011, and followed by ClearPass in 2012, doing the exact same thing, just combining a Megapod vendor and another .1x service. What we then see is around that same time, we see a new trend. We see a very slow start of cloud-based identity services, right? We see the emerging of Azure AD and Okta Cloud Directory services. That's slow start, but this is when it started. And then later on, we see in 2015-ish, we see the explosion of IoT devices, right? But what we see at the top, really, we see lots of upgrades, lots of features being added to the existing products, but fundamentally, architecturally, we don't see a lot of a change. So that leaves us in here, right? So this is where we are. If you look at the left-hand side, you see that a typical AAA server that you see today, over time, the features have been added. All the integrations have been bolt on, and they're all part of the same monolithic single server architecture, right? So bugs creep in, feature dependencies grow. It becomes harder and harder to maintain this within the same server. If you then look at the right-hand side, this is a typical NAC deployment at any scale. You need to deploy multiple server appliances or VMs that would do the heavy lifting, the authentication. You would need to have some clustering on top to manage the whole deployment. And today, this is actually a customer problem to solve. You need to design for redundancy, for scale, for high availability. And if you have a global deployment with different geo regions, you need to think about latency, you need to think about all of that. Plus, what about feature upgrades, software patches, security patches, right? Today, that's a typical challenge and typical problem in a NAC deployment, right? And with all that, today NAC solutions are alien to the network, right? They're an overlay solutions most of the time. There is nothing that exists within the network and the NAC that could merge the two worlds together. So what do we do? We will mystify NAC. So we are solving all of these challenges, right? We are replacing that with a Mist Access Assurance service that is integral part of the Mist Cloud. It's native to the Mist Cloud. It's tightly integrated into the network and network operations. It's microservices based. It's geo-aware, and everything that you knew and loved about the Mist Cloud is now extended to authentication service that we are launching today. Let's actually go and take a look at the demo. I'm going to switch to our demo. It's full screen. Now, I said it's natively integrated into the Mist Cloud. So voila. What we have here is you see wireless, you have wired and SD-WAN network operations. We're now adding access assurance as a new service, right? So you have full stack network operations, you're adding NAC and AAA services right within that same cloud interface. Now, how do we configure it? How do we use it? One of the challenges we've seen traditionally with any existing authentication service is the complexity associated with configuration, complexity associated with the deployment. Typically, that means you need to have an expert on the team that understands all the various vendors, radius, how to integrate this with external identity sources, all of that. Now, what we are doing is we are simplifying this into an authentication policy builder that gives you the flexibility, but allows you to actually understand what you're doing and allows you to read what you've done if you come back to this a year from now. So what we're doing here is on the left-hand side, we are matching on certain criteria and certain conditions. So we're trying to identify what type of device, what type of user is trying to connect to our network. For example, let's take a look at rule number 7. We're looking if it's a wireless user, if the client is using TLS or certificate-based authentication to connect, if the certificate of that client is either issued by Juniper or another CA that we've specified here, and that user is part of employee group in the identity provider. If all of these conditions match, then we move to the right-hand side and we're saying, okay, what do we want to do with them? We want to allow them on the network, great. We also want to move them to a specific VLAN, right? That could be a VLAN name. It could also be a GBP tag if we want to do a microsegmentation on top of that. And we can assign a role, right, to apply a policy later on. So everything that you see here is driven from that one screen. How do you assign those conditions? So we have a concept of labels that you could select from the labels that you've already created before, or you could create a label right from here. For example, you may want to look at a specific directory attribute. Maybe you just want to look at finance users, right? So you could select the label type, directory attribute, that group, and just say, I'm looking for anything that matches finance group. That's it. Then you will go and select it right from here. Easy. Now, that's all great. So how do we turn this on for, say, our wireless network? How we turn it on for a .1x SSID? So if we move over to a wireless templates, typically when you're looking at configuring a .1x SSID, you need to go to your authentication server. So you need to add each and every radius server one by one, configure the right shared secret, add each and every AP as the radius client. That's tedious work. It's creating a lot of issues, a lot of mismatches, lots of customer complaints and customer tickets. What do we do with our service? Well, we select Mist Authentication Service. That's it. It automatically programs all the APs. It automatically tells them how to reach the authentication service. And that authentication will always be geo-aware. So, depending on where the APs are, they will always hit the local authentication service button. Okay, that's second issue. Now, what about visibility? So one of the things for us, and when we say, we're launching an integrated cloud authentication service into the network, we also want to have integrated experience when it comes to visibility. So when we look at the client side, we want to see, okay, how do you validate that the user is actually able to authenticate, authorize, get on the network and be able to pass traffic. I don't want to jump between 10 different products and different screens. I don't want to look at logs and displays in that place to find that out. I want to look at a history of a specific user connectivity experience and take a look at what's happening. Well, what we've done is we've extended our client insights, our event stream that we've already had to our access assurance service. So what we are doing here is, okay, we are looking at all the historical connection stages the client went through. So client, in this case, it's using certificate to authenticate, it's presenting its certificate, then it trusts the server certificate, but then we are doing an IDP lookup. In this case, we are using Okta. We're directly talking to Okta to fetch the user group membership information. We want to make sure that the user account is still valid, all of these things, right? So we're getting all the roles from Okta for this given user. Finally, we're saying this client is allowed access to our network. We're assigning a specific VLAN. We're assigning a role that we can later on apply as a policy. And then you can also validate all the next stages of connection as the client actually goes onto the network, gets the AP from the right VLAN as assigned by the NAC, and is able to pass traffic, right? Everything in one place. But what you also see here is, in this client allowed access event, I see this auth role. So if I click on it, we're actually telling you, okay, this particular user hit this specific authentication policy rule. Okay, so this is how we can integrate this event stream. Okay, so you say that's all nice, but things are working fine. What if things are not working quite as expected? So historically, if we look at just events and data that we're gathering from what the EP can see on the wireless side or what the switch can see on the wired side, if the client is failing that 1x authorization, well, we're saying we got a reject or we got a timeout. And then since we never control the other side, we had limited visibility into that piece. Now, with access assurance under our control, we have the full picture, right? In this case, we are actually seeing the client is failing to authorize because the client doesn't trust the service certificate. That's it, right? This is a one-stop shop. We're saying this particular user is having a problem because it doesn't trust the servicer. Go and fix the client configuration. Done. Okay, you would say, that's all good, but I don't want to go through all the events and scroll through them and to find out what was the issue. It's fine. Let's go and maybe talk to Marvis. Maybe let's try and find out, is there a simpler way to troubleshoot issues, right? So what we could do is we could try asking Marvis, what was the issue with Slava last Thursday? Okay. Oh, there we go. So immediately, Marvis went through all of the data we have. It found the specific user that matches specific username. It went through all the events, all the raw data that it showed just previously, and now it can give you an answer. Okay, that particular client, it had an authorization issues because of the client cert that was expired at that time. That's it. Okay. And obviously, since we are troubleshooting this on a per user basis, the next logical step is how do we expand this into Marvis actions? How do we troubleshoot things at scale? How do we find issues that are affecting groups of users? How do we find issues that are affecting maybe a specific site, or maybe just something as simple as let's find some persistently failing clients. Let's find some top offenders that are continuously hitting our network with authentication requests and they're continuously failing. So in this case, we can just say, okay, this particular client is trying to authenticate to a network all the time, and it's continuously failing. Please go and check. Or if you have an authentication failure at scale, Marvis action will be able to grab this for you, find out, and highlight where you need to look at.
So Slava, Raymond here. I have several people asking from the online community asking how about the integration or compatibility with Eduroam?
Eduroam is work in progress. We are planning to support Eduroam. As of today, we're still working on that. So most likely by end of the year.
Excellent. Slava, my questions are revolving around just the functionality of putting NAC and Radius into the cloud. Historically speaking, that's been challenges around latency and then availability in the event of an internet failure. How are you solving those problems?
So there are two things there. One is, I'll start from the latency first. So we build a geo-aware service. That means that if you, let's say, have sites in Europe and United States on the East Coast and West Coast, the APs from each geo region will be automatically redirected to the nearest authentication service pod that we have deployed. Right? That process is automatic. This way, you get the best latency, actually the least latency when it comes to authentication. Yeah, that's number one. That also is true in case of, let's say, something happens to a specific authentication service cloud, say in United States or on the East Coast. There is always another one to fail over to, right? So we are definitely taking this very, very serious from a perspective that this is a mission critical service, right? Because this is not that, for example, your AP is not connected to the cloud. Well, you're just losing management. This is right in the client data path, right? We want to make this right. This is where the architecture is very important.
Well, so I guess let's just get right down to it, right? I've got a site that's on a crappy internet connection that has a 300 millisecond latency out to the internet. How on earth are you going to expect them to authenticate in a reasonable amount of time if your Radius services are on the other side of that connection? Do you do any proxying on site? Do you do any caching? Do you do anything at all to make that burden less?
So right now we are relying on the fact that we will have global presence, right? So we will have the closest pod near to you. If you have a crappy internet connection, define crappy, right? And like nowadays, when we talk to customers, some of them have like 3 to 5 to 7 redundant internet connections, not one, right? Because that's also been historical thing when you talk about radius, specifically latency. People were thinking WAN, like MPLS and things like that, because you're sending this over to the data center. In our case, this is pure internet traffic. The other thing is our transport, our authentication is done using RADSEC. So we are not suffering from any MTU issues, loss issues, because it's all TCP based, right? We control that link end to end. So hopefully that answers some of it.
Okay. Yeah. Thank you.
Is there another certificate that you have to deploy down to the clients to trust your Radius environment?
So by default, we will use our own certificate that's signed by your org like Mist Organization CA. If you would like us to present your certificate to the clients, you can import your custom server cert into the dashboard. We'll just present that. So, two options.
And just to piggyback off Sam, there's no way to have the access point in the event of an internet failure, the access point just fail open or just kind of accept all connections or kind of handle that way.
In case of wireless, there is no mechanism of fail open on that one, unfortunately, right? Unless you host a radio server somewhere.
Yeah.
So the answer is no. When there is a loss of internet connectivity, the currently connected clients will stay connected, and the clients that are roaming, they will keep roaming. That's not changing. Only the new connections would be affected at that point. In case of the wired switching, right? In case of the wired devices, obviously there is a fail open logic because wired allows us to do that. There is also caching option on the switch that you will be able to do. But fail open is there.
So currently, it's the first first phase is this is just wireless, right? Wired is not here. Is that correct? But if wired
is there, wired is there. I should have actually showed this. So wired. How do you think we configure wired ports? Well, you go to the switch template, and voila, your authentication server is Mist authentication. Same as with the wireless SSID, right? Same thing. We support this on the ETs. We support this on EX switches that we manage. And then you would go to your port profiles. You would create, let's say, a secure port profile where you would enable .1x and MAM. You assign it to all of your front-facing ports, and then at that point, NAC will decide which VLAN to assign to which client and which user based on its identity.
One more question. Will you offer this as a third-party service to other vendors as well, to other parties?
So what we are doing is for third-party infrastructure that we are not managing directly, we will leverage the Mist Edge as the authentication proxy platform. So what you will be able to do is say, go to your Mist Edge, enable Mist authentication proxy. At that point, you could point your existing third-party infrastructure to the Mist Edge as your radio server. From there, Mist Edge will take it over and send it to the cloud and for authentication.
Okay.
So that's going to be your gateway, your authentication proxy into a third-party vendor.
Okay. And so follow up on that, will there be a certification for this as an education in the education path?
Oh, great question. So what we've actually done today, I think it must be online now. We've launched a new Access Assurance course on the Mist courses. So you should be able to see it now, and it should be assigned to everybody. And yeah, at some point, definitely we will take a look at the actual official certification.
So back to Sam's point, you're using Mist Edge as a authentication proxy for third party. Why can't we do that with first party? That's all Sam's complaint about a weak internet connection.
Okay, so I'm not gonna commit to anything yet, but see, we are looking at this product, and we have to be focused, right? So first, we are looking at the architecture. We need to solve this architectural problem, how to deploy this in the cloud so it scales, so it's reliable. It's a reliable service. Then we add features on top of that.
Okay, and if I may just
as a proxy is a proxy.
If I may just add one more point, Slava, to the question, is basically Juniper switches, Mist access points all support RADSec natively, right? So it's fairly simple for us to put the architecture in where we natively terminate RADSec connections from our infrastructure. What do we do for third party? Some of the third party vendors do support RadSec, some don't. That is why we mandatorily commit to putting in a Mist Edge. Over time, as Slava kind of alluded to, Mist Edge could be a caching proxy as well for all services. But right now, like to Sam's point, if you really have a flaky WAN link and like if you have a WAN outage today, if you in a distributed like environment and fraction T1 lines, you're really like deep in the water with WAN issues. In that case, like what would you do? Your only solution is to put AP caches, like cache radius servers on site. Correct?
In my instance, I'm talking about a DIA circuit that's a 50 meg circuit from Charter that has well over 300 millisecond latency. Before it even leaves the Charter network, I've already picked up about 300 milliseconds of latency. Right. And so I'm not talking about FRAC T1s or really old stuff ISDN lines, right? I'm talking about high bandwidth circuits that are also high latency circuits.
Got it. The only thing I will say now, Sam, is that in some of the POCs we have done, there have been customers over the ocean terminating their RadSec connections, like out into our the NAC service, the authentication service, without any perceptible latency. I'm going to leave it at that and say that in the future there might be some evolution, right?
Thanks.
And let me add to that, Sanjay. We've actually tried this by doing authentication from Australia, since all the way to the West Coast, all the way to the East Coast, with the almost 400 millisecond delay. So that authentication happens flawlessly every time.
I'm not worried about
with the latency part.
I'm not worried about the authentication happening. I'm worried about a voice over IP over wireless client that's roaming from one AP to another AP that needs to go out and re-auth. You do a 400 millisecond roam, that's just garbage, right?
Right. Yep, I agree. But for roaming scenarios, I think we're slowly but surely moving to 11R cases where you're bypassing everything, right? So you authenticate once, and then when you roam, you skip all of that, including four-way.
For the licensing on the Mist Edge, when you're using as a proxy, will that be something separate queue or separate licensing method, or it'll be the same exact pricing what it is right now?
This is a service that will require a subscription. The subscription will be based on the concurrently active number of clients that we see over a week period. And the only thing we are looking at is really the number of client devices that are using the authentication service concurrently.
So even if I'm using proxy,
talking about Mist Edges.
I think, Sava, the question is that question from Ali is if you're using Mist Edge as a proxy. So today, you're going to basically put in a Mist Edge appliance or a Mist Edge container on-prem, and we offer the appliance and the VM. There is no Mist Edge subscription, as Slava alluded to. All you need is the active, concurrently active client subscription. And by the way, when we cover, Slava is going to show us some progress on IoT assurance.
Okay.
I'm happy to say that it is the exact same subscription that will allow you not only PPSK-based client device onboarding, but also now .1x. So everything is getting subsumed under the access assurance umbrella.
Okay.
I have a quick question regarding the third-party IDPs. Is it fully integrated in the sense that it's leveraging that IDP as the authentication source? In other words, then it would tie into MFA and other capabilities on that IDP, or is it really just for user group assignment, things like that?
So I get the question. So there are two ways how we can leverage IDPs today. One is as I showed, to get the group information, user account status and all the attributes that come with it. The second is to use IDP as an authentication provider. In that case, you would have to use something like IPT-TLS to authenticate users using their credentials. Saying that, so for example, this will work with Okta, this will work with Azure, by authenticating user credentials. Saying that, if you look at the device OS developments, you could see what Microsoft is doing with latest Windows 11 updates and enforcing credential guard that actually blocking any form of password-based authentication on .1x and VPN. So what we are seeing is a trend where everything is moving to certificates only. It's a slow trend, but it's starting to show up. But to answer your question, you could still use IDPs as authentication sources.
So in terms of the policies, how do I put this? How stupid can I get? Because I've got some policies right now that are, I have been told are pretty stupid by the ICE consultant that helps me when I get in over my head. For example, can I key in on for example, if I might provision an Intune device with a different certificate, something different in the OU than a Jamf managed device, so that in my authentication policy, I can key off of that, right? These all look pretty simple. I'm not seeing anything really like I'm digging into fields and certificates and making policy choices based on those decisions. Is that functionality there?
So thank you for asking this question. The functionality is definitely in there. So you could create a label, again, just a condition. You could look at virtually any certificate attribute you want to look at. You can match on, let's say, a subject, just say if it's OU XYZ, then we're going to match on that, use that as your condition on the left, and then apply different policy based on that. This is very powerful. We've been asked about this by actually quite a lot of customers that are issuing different certificate subjects to different types of devices or users. So yeah, definitely.
Good to know that misery loves company.
I got one last question about this. So as far as my understanding is, this is cloud-based directories, right? Like Azure, Okta, and all that. I'm just curious, what if somebody doesn't have that and they only have just, I don't know, local Active Directories, locally deployed certificate-based servers and all that kind of stuff? Is there some kind of agent or something again, or can we use again Mist proxy to somehow integrate the cloud radius with that?
So Ali, what we see is there are customers who would say, I only have local Active Directory, and I'm using this today with my current Radius server, right? But the next question would be, oh, but are you doing any single sign-on today? And they'll say, yeah, we have Azure. Okay, hang on a second. So you actually are doing a hybrid cloud deployment model. Yes, you're using your local Active Directory with your current Radius server, that's fine. But all your users are in fact already in Azure. Most of the time, we don't need to talk to the local AD because there's something in the cloud that has all the user records. Saying that, if you find that off case of, at this point, really like couple of % of customers that have nothing in the cloud, you could still use secure LDAP from our cloud to your local Active Directory to open it up. That's the answer I would give.
And forgive me if I'm jumping ahead, but are you going to be able to discuss integrations with MDM platforms like posture checks against Intune or Jamf or?
Currently actively in progress. So what we are looking at is bi-directional integration into MDM providers. Initially, there will be Intune and JMF Raw. So the idea is that we will constantly communicate with say Intune or JMF and see if the client device, if the endpoint is in a compliant state, what's the enrollment status, if it's a corporate device or if it's a BYOD device enrolled in the MDM, all these attributes, right? Based on that, you can apply your policies. The key thing here is it's a bidirectional integration. That means that, say, something changes on the device after it's authenticated. right? For example, somebody disables firewall or forgets to update the antivirus, then, for example, Intune detects that this device is out of compliance. There is a notification back to our cloud. At this point, we'll be able to act and move the client into, say, quarantine or disconnect it altogether.